Recommendation system for monitoring the energy value of consumer food products based on machine learning by Nazar, Oleksiv, Oleh, Andrii, Vasyliuk, Ihor, Rishnyak, and Lyubomyr, Chyrun. Proper nutrition is one of the conditions for longevity and healthy living. After all, most health problems are related to what we eat. By following simple rules of healthy eating, we will feel much better. However, it is pretty challenging to track your diet daily because the day of an ordinary person is usually quite busy, and there is no place to calculate the caloric content of foods and monitor your diet. Moreover, you need to stabilize your diet and determine your diet to get the most out of constant physical activity. Therefore, creating a system that automates these processes is necessary for today's reality. A team of researchers from the University of Massachusetts has developed a neural network that can make a list of ingredients and form a recipe for food. The input data for the system's operation are images of a predetermined format. The authors have created an open database of about 1 million different subject images to teach the system. The database was formed by collecting information from open sources. The basis for this approach is culinary sites and access to food service databases. The article follows that the neural network works on the principle of joint embedding. It divides images into vectors with products or ingredients. The neural network compares the formatted input image with the most similar picture of the recipe, which is compared with the input element under the influence of linear transformation. The researchers used the neural network in actual conditions and compared the available results of the system with those that people themselves gave in a random survey. Under these conditions, the accuracy of the neural network is 83.6%, while the survey showed that the accuracy of recognition of products included in the dish is 81.6%. Recognition of dishes in general is challenging due to different national dishes, varieties, cooking styles, and the inherent complexity of modeling food from its visual appearance. First, you need to adapt the photo frame based on the rejection of unlikely categories located far from the test image. Then reformulate the problem using a probabilistic model that combines dishes, restaurants, and places. This model is used in 3 different tasks: food recognition, restaurant recognition, and space improvement. To build a goal tree, we connect all the system's goals. After that, we will select the main goal, which will serve at the top of the tree, and the subordinate objectives of the first and second levels. The primary purpose of the developed system is to create an information system of dynamic and adaptive control of the human diet based on machine learning. To achieve this goal, you need to analyze the subject area, design the system, and work on the implementation. The goal tree shown in Figure 1 allows you to create a compelling and complete hierarchical structure by decomposing the primary goal. To select the appropriate type of information system, we use the hierarchy analysis method. As alternatives, we choose 4 types of information systems: information retrieval A1, information retrieval A2, decision support system A3, and intelligent information retrieval system A4. The type definition of the information system will be evaluated to 6 characteristics: novelty of the developed product C1, recognition quality C2, the flexibility of implementation C3, productivity C4, speed C5. We use the relative importance scale of priorities to calculate the expert assessment presented in the table. We depict the relative importance of one criterion compared to others in the matrix of comparisons of characteristics. We create a matrix of alternatives comparisons and identify the information system type. Thus, the hierarchy analysis method is the chosen information system to support decision making. To develop and maintain an ontology describing the recommended system for monitoring the energy value of consumer food products based on machine learning technology, we use the standard that is part of the IDEF family in software development, IDEF5. IDEF5 method is an ontology by collecting statements about natural objects, their properties and relationships, and presenting this content intuitively and naturally, reflecting the human perception of a particular area. There are unique ontological languages to carry out the process of building IDEF5 ontologies. Schematic language is a graphic language that is specifically designed to present primary data in the form of ontological information. This language allows you to naturally offer basic information about the initial development of the ontology and supplement existing ontologies with new data. This language will enable you to build various charts and diagrams in IDEF5. The purpose of graphs is to use visualization to present basic ontological information. Revisions and clarifications is a structured text language that allows you to describe the ontology elements in detail. Let us construct a classification chart using schematic language. Figure shows a diagram of the classification of nutrients. As you can see, organic nutrients are made up of proteins, fats, and carbohydrates. We believe that this classification within the system is necessary because a living organism cannot live and die without them. Figure B shows a diagram of the type of food intake. Each meal takes place in a different time range, so we use such categories as breakfast, early meal, lunch, midday meal, supper, a meal in the final phase of the day. Any dish can be classified in the classification system. Therefore, we distinguish the following dishes: main, sweet, salad, snack, and drink. This classification is given in Figure 8. The input also includes a barcode that allows the system to have information about the food composition without working with the product directly. Figure B presents a diagram of the classification of input resources. The general combined scheme of processes is presented on this slide. The implementation of IDEF diagrams was chosen to detail the structure of the information system. The conceptual model of the process product recognition and diet control is shown in Figure 1. The input parameters for the full functioning of the system are data on the calorie content of products, data on dishes, a data set with images, user features set in the settings, and an authorized profile for access to the API with barcodes. One of the key parameters influencing the formation of advice and a consumption plan is dietary norms. The initial result of the whole system can be the final calculation of calories and the establishment of recommended theses on nutrition and diet. The software product is designed based on 3 levels of architecture, which consist of the following levels: presentation, business logic, and database access. The figure shows a visualization of the system architecture, the relationships between the layers, and the related technologies for implementation. The advantages of this architectural solution are code maintenance and support. Each level is independent, so changes in one class do not lead to changes in another. Flexibility. Each level can be managed and scaled separately. Reuse. Independence allows you to use levels within different systems. Faster development process. Various specialists can deal with specific areas. Front-end specialists, representation group. Back-end engineers, the introduction of business logic. Database administrators develop a database model. We will describe a database that is directly related to the lowest level and is the central place to store data in the system. The database satisfies the 3NF requirements and consists of the following tables: users, roles, genders, meals, meal times, ingredients, and measures. The scheme is shown in the figure. Database level validation was created during the development, which will not allow you to create a tuple if the required field is empty or the length of the area exceeds the allowable limits. The program is written using the C programming language and JavaScript. The SQL standard was used to write scripts to interact with the database. The following development environments were used during the development: Visual Studio 2019 and Visual Studio Code. Microsoft SQL Management Studio 2017 was used during the development. The JIT version control system was used using JIT Bash. The program is designed to control the daily diet and automatic calorie counting. This system's focus suggests that its implementation is possible in various spheres of life. Currently, there is only one mode of operation in the program: custom. The limitation of the program is the presence of a device with Android iOS version 8 and higher. The device must be equipped with a camera module and access to the internet for the whole operation. The system requires access to these device parts to comply with all usage rules during the first startup. To start, you need to log in to the Pocket Diet Coach application shown in Figure A. Logging in the system is in Figure B. Here you need to enter the login and password of the created account. The main page is shown in Figure C. The navigation menu is shown in Figure A. The photo mode is shown in Figure B. Activity statistics are presented in Figure C. Consider the efficiency of the system and the compliance of the task to the results of work. After the user downloads the application, he sees the page shown in Figure A. After a successful login process, the next login will redirect the user to the home page. The user can go to the registration page or login with a pre-created account on this screen. After entering the required parameters, the user will fill out the registration form, which is shown in Figure C. Initially, the information in the profile is filled with the data that were entered during registration. You can change them by clicking the appropriate option in the upper right corner. The user's page lists the main parameters: name, age, country, weight, and height. In addition, the profile shows user activity. The activity is represented by an activity schedule that indicates the number of actions during a given day. A graph is an array that consists of an object that contains the data and the number of contributions for a given day. Accordingly, the richer the square, the more activity the user has spent during a specific date. Particular attention is paid to the analysis of consumed substances and dishes, so the information in diagrams is presented in the user's diary. Figure A shows a line graph showing the number of calories consumed in the last 7 days. Also, Figure A is a circle chart showing the relationship between the amount of food consumed and time. The system has 4 time ranges, so the circles are also 4. The relevance of the topic is confirmed by the massive demand for similar systems of similar scale in the market of mobile applications. The number approves of downloads on different platforms. The advantages and disadvantages of alternative solutions are summarized in the table and summarize the result. Various architectural solutions and algorithms for neural network training methods are analyzed to design the system. The efficiency of their implementation in different areas is compared. The appropriate form is selected and the optimal initial data set is set. All information was analyzed with the help of scientific articles, thematic literature, etc. The result of the system analysis is the creation of a goal tree based on an integrated approach. The system's primary goal is established, and its decomposition is carried out at different hierarchical levels. The result of successful performance of work is the creation of a system that satisfies all tasks set, recognition of products, automation of the process of counting calories, formation of councils, and sending of notifications. All results are supported in the software product description and user manual. The user manual describes the appropriate use of the system given the necessary conditions for a startup. The system's functionality is supported by images that show the sequence of using the system step by step. Thank you for your attention.